Hello, let's see chemoreceptors and their role in regulation of respiration. There are two chemoreceptors, one is central, the other is peripheral. As the name says, central chemoreceptors are located in the brain, in the ventral surface of the medulla. The central chemoreceptors are sensitive to CO2. The CO2 can cross the blood-brain barrier while H+ cannot cross the blood-brain barrier. The CO2 in the brain combines with H2O in the presence of carbonic anhydrase, leading to the formation of carbonic acid, and this leads to the formation of H+, and this is a direct trigger for the central chemoreceptors. The peripheral chemoreceptors, on the other hand, are located in the carotid and aortic bodies, and they are sensitive to hypoxia. But how? The glomerulus cells that are located in the bodies have O2 sensitive K+ channels that closes in response to hypoxia, and this leads to opening of the calcium channels, and this depolarizes the cell and leads to release of dopamine, which directly triggers the brain in response to hypoxia. In a nutshell, the central and peripheral chemoreceptors, the central chemoreceptors are CO2 sensitive, the peripheral chemoreceptors are O2 sensitive, but the common stimulus to both of them is increase in H+, which is reduction in pH, that is acidosis. This explains why a DKA patient hyperventilates. The other common stimulus to both of them is reduction in blood pressure. And so far we have seen theoretically, but clinically speaking, if a patient is hypoventilating, this leads to hypoxia and increase in CO2, and this leads to acidosis, and this will trigger both the central and peripheral chemoreceptors. As said earlier, the chemoreflex is hyperventilation leading to CO2 washout, and this will lead to CO2 and H+ fall and increase in O2 by means of increased air entry into the lungs. Thank you.